IoT suites are a set of cloud services that act as your dashboard for IoT projects, assisting you to easily mine and analyze different types of corporate data, creating new insights, and predicting outcomes. The Ruckus IoT Suite is a collection of hardware and software network infrastructure used to enable multi-standard IoT devices access to the network. The IoT Controller part of the suite is a virtual controller that performs connectivity, device and security management for non-Wi-Fi devices. Generally speaking, when using the IoT Controller through the web interface, a user has to log into an administrator account. The exploitation of these vulnerabilities work by sending a crafted HTTP request to the web interface. As can be seen, we can download a backup file without being required to log into the system with administrative privileges or any other privileges. Even if the administrator of the IoT controller has not created a back file, we can manipulate the backup service and control aspects of it without requiring authenticated access. The backup service allows the administrators of the IoT controller to create backup files which save the configuration of the server and can be used to restore it in the future. While you would expect such a sensitive service as the backup service to be exposed only to administrators, even an unauthenticated user can generate new backup files, delete existing ones, get a list of the currently available backup files, and of course, as we have just seen, download them. As can be seen here, we are creating a backup file, downloading it, and finally, deleting it. This is all done without a trace of the attack. The data stored in the backup should be regarded as highly sensitive and should not be accessible to anyone but the IoT Center administrators. If we look at the contents of a backup file, which is an archive file, we can see that it holds sensitive files. The most critical and sensitive files found in the backup file is the CA key and the private certificate key used by the IoT Center to encrypt communication between it and the IoT devices it is configured to connect to. An attacker holding this private certificate key can also decrypt and view all data being sent between the IoT Center and the IoT devices. Another file that is stored in the backup file is the configuration database, stored as a SQLite file called config.db. Config.db holds the settings such as API keys. These API keys are related to plugins used by the IoT Center. By having access to them, we can have unrestricted access to the plugins. A few plugins arrive bundled with the IoT Center: Contact.io, Tracker, and iBeacon. These plugins enable connecting to different IoT devices and gather all kinds of information through them. In addition to the vulnerabilities mentioned, we can also set up a few options in the server remotely using the configuration service. One of the most useful of these configuration values is the option to set the DNS server value. By performing this attack, you can configure the server to query our malicious DNS server and utilize it to perform man-in-the-middle attacks. Because this IoT Center is built mainly for large corporations, such as hospitals, banks, and academic campuses, the vulnerabilities found in it pose a large threat to a lot of people. They allow the disruption of devices and potentially exposing the user privacy in these corporations. As Ruckus IoT Center can integrate with motion sensors, smoke detectors, security systems, e-locks, air filters, and much more, a compromise of the IoT Center poses a great risk. This vulnerability and many others will be discussed at SSD's annual security conference, TyphoonCon, which will take place on June 14th in Seoul, South Korea. This year, we will be hosting 2 days of amazing industry leaders conference and 3 days of extensive training. To learn more, go to typhooncon.com, visit ssd-disclosure.com/typhooncon, or simply follow the link below for all details.